Hi, we continue with the one small part under 3.3 electromagnetic induction, that is to compare between direct current and alternating current. Okay, let's look at the comparison, the differences and similarity. Okay, part 1, the definition. Okay, a direct current is a current that flows in one direction only in a circuit. The magnitude of direct current may be constant or changes with time. So you can look at the graph. So the first graph shows current flow in one direction only, positive direction this side, and then the magnitude constant. For example, current from a dry cell or battery. Okay, and the second graph shows magnitude changes but still in the same direction. So this is also direct current. For example, current from DC generator. This one we discussed before. Okay, for the AC current, an alternating current is a current which flows to and fro in two opposite directions in the circuit. It changes its direction periodically. So meaning every half cycle. Every half cycle. Okay. So for example, you can look at the graph for the AC. So for this graph, you can see the magnitude constant, but here positive, negative, and then positive, negative. So you can see the direction keep changing. For the first one, magnitude is constant. Second one, same thing, positive direction, negative direction, positive. So meaning direction keep changing every half cycle. This one magnitude changes. So magnitude changes, as example, produced by AC generator. Okay, so this one is for AC current. Okay, look at the differences when passed through a capacitor. Direct current can flow through resistor. So look at the diagram here or the circuit here, but cannot flow through capacitor. So capacitor will block DC from flowing to this bulb. So DC can flow through this resistor, meaning the bulb here can light up. Okay, if you look at here for the AC will cause capacitor to be charged and discharged, or we can say capacitor allow AC to pass through. So in this case, both bulb will light up. AC can pass through resistor, can pass through capacitor. Okay, so that's a difference. Okay, the similarities, both DC and AC have same heating effect on the filament of bulb and can light up the bulb. So both can be used. You want to light up the bulb, you can connect either DC current or alternating current. Look at this one, the graph to represent the AC. So we have a graph I against T and V against T. So the current increases from 0 to maximum value of positive IP, okay, at A, and back to 0 at B, and then reverses direction and increases to negative IP at C, and back to 0 again. So IP, we note defined as peak current. VP is peak voltage. Okay, the time taken for complete cycle from O to D is called period T. From O, A, B, C, and D. So meaning this whole part. So this whole part from O to T, we call it one complete cycle. Okay, so the time taken for this one complete cycle is known as period T, capital T. So here it should be capital T. We just can read from the graph how many seconds. Okay, so the time taken for the complete cycle from O to D is called period T. Thus frequency F equivalent to 1 divided by period. So we can calculate frequency by using the formula 1 divided by period. In Malaysia, frequency of AC supply is 50 Hz. Hence, period equivalent to 1 divided by 50, so 0.02 second. What is the meaning of 50 Hz? 50 Hz means every 1 second, the current will reverse 50 times. Okay, change direction 50 times per second. Okay, look at the example, calculation example. So this is for the V against T, same thing. The maximum value here is the peak voltage. Okay, and the time taken for the one complete cycle, we call it period. Okay, get the graph here. Figure shows AC current with magnitude that changes with time. Okay. So what is the peak current? So just read from the graph. What is the value here? This is IP, peak current. Okay. So from here we get 5. So IP equals to 5 ampere. Okay. What is a period? Period you can read for one complete cycle. This is one complete cycle. So what is the value here? 0.04 second. So just write down period T 0.04 second. So what is a frequency? 1 divided by period, thus 1 divided by 0.04. So you will get 25 Hertz. Okay, so that's how we solve problem involving alternating current. So that's all for this part. Okay, so meaning we have ended the 3.3 electromagnetic induction. So we'll continue with 3.4 transformer later. Bye.